In this tutorial, we're going to have a look at the difference between assemblies and single components with multi-bodies. We're also going to look at how to create an assembly using saved multi-body parts. We're also going to look at how we can manipulate individual components within an assembly. By now, your CAD model should look something like this. You should have 8 solid bodies. So we have 1 that forms the back cap, 2 that forms the heat shield on the top, 3 that forms the grip on the front, 4 that forms the right-hand side of the handle of the main body, 5 the left-hand side, 6 the trigger, and 7 the rear hand grip. Now, so far, all these components have been made with the one part file. So we've been using multi-bodied parts. This is a multi-bodied part file, so they're all one component, but just different bodies of the one component. Now, that's a really powerful thing that SolidWORKS allows you to do, but being in the one part has some limitations. What we need to do next, what we're going to do in this session, is to separate each one of those solid bodies and create individual parts or components from each of those solid bodies. Once we've done that, we can put all those solid bodies back into an assembly, and then we can manipulate them and do a variety of tasks that only can be done with individual components in an assembly. So at first glance, a multi-bodied part sort of looks like an assembly, and you can do a lot of construction in a multi-body part, but it's not an assembly. And there are some things that only are really possible in an assembly. It's also a little bit less confusing sometimes when you're working within an assembly, because you can work on individual components one at a time. But when you have a product where lots of the components share the same geometry, as in the hairdryer, it makes a lot of sense to make an initial part, a single part, with multi-bodied components in the part. So when you have a product that shares a lot of the geometry amongst components, it does make a lot of sense to use this approach of making a single part with multi-bodies. And the reason for that is that these components can share the same geometry very easily. Then you can split them off into separate parts, put them into an assembly, then manipulate them independently and put independent features on them while they're a separate part. Creating individual components is really quite easy. All you have to do is to go to the solid body part, right-click on the solid body you want to save, go down to Insert into New Part, and you can give it a file name, and this is probably a good time to call it something that's a little bit sensible. So in this case, I'm going to call this the rear cap. And you can also propagate the visual properties. Now, I've already put visual properties on these components, or these solid bodies within the one component. So they might as well follow across and be saved as the new part. Otherwise, they'll lose all their visual properties. And hit save. The newly saved component will pop up, and then you can start editing it from there or save it into an assembly. Now you can go back to your original base part and save out all the other solid bodies into new components. I'll just go ahead and do all these. Once you have saved all the individual solid bodies as new parts, you can then open up an assembly and put those parts into the assembly. So we'll go File, New, Assembly, and you'll see on the left-hand side, all the parts, because they're actually opened already, they are ready to be imported into the assembly. Now, when you click on one of these components, you can drag and drop it wherever you want. But if you just click on the OK button, what it will do is it will align that component with its origin over the origin of the assembly, like that. Now that's really useful because every one of those components that you've created shares the same origin because they all came from the same base part. Continue to insert components like the left side. We can just hit OK, and that will be in the right spot. And again, we'll go through and get all the components. So now you have all the components in an assembly. And I know this looks very similar to the single part that you had, the multi-body part, but you'll see that these are just components. These are all individual components, and they can be edited individually. You're also able to create exploded views and a variety of other functions that you can only do within an assembly. So SolidWORKS is quite powerful in the way that it's able to deal with multi-body parts and assemblies. It might take a little while to get your head around the difference between the two of them, the two modes, but they are very distinct. There are several things you can do in an assembly that you can't do in a multi-body part file. One of which I mentioned before was an exploded view. Another is the ability to import existing components and bring them into an assembly. So far in the multi-bodied part file, we've taken a top-down approach, which means we've created some geometry and then we've made parts from that geometry that share the same geometry. But quite often you take a bottom-up approach, which means you start off with individual components and then you bring them into an assembly. So in this case, I'm going to insert another component. It's going to be a fan assembly. So let's say we have a fan. This is, say, taken from a catalog, so it's a file that we didn't create ourselves, but this is the fan assembly that we're going to be using. You simply can't do this in a part file. It just doesn't work that way. So an assembly file is what you need. And in this case, to locate this component, at the moment we can move it around all over the place. We haven't located it where it needs to be. And we're going to use assembly mates to do that. So this fan needs to be in the middle of the component here. I'm not exactly sure where, but for the purpose of the exercise, I'll just locate it using assembly mates. So I'm going to use a coincident, a concentric rather, mate between this face and this circle, the outside of the fan. Now that's when you select those two faces, that's the only option you have because they're both cylindrical faces. In this case, this is a slightly conical face, but it's viewed as the same thing. So the center line, they both have center lines, and that center line will be matched up. So now that has that concentric mate, and fan has got to sit in here somewhere. Okay, what I'll do is just hide one of these components so that we can see what's going on inside. So that's where the fan sits, and let's say we need to position it a little bit more accurately. I can put an assembly mate on. Okay, let's say to put another mate on here, we want to put a distance mate between, say, that vertex there and this face here, and we can put a distance mate on that. It tries to put a coincident mate first, but if we tell it we want distance, it'll go back to there. And let's say we put in, it actually looks pretty close there already, so let's just put in 35. So now we've got a fan component, and let's say there's another couple of components we want to put in. So let's say insert component existing. So let's say we need to put another component in there. So insert components, and we have the heating element already. Click OK. So now that's just dropped it in. There's no mates on. So we go insert component, heating element. We'll just drop it there for now. Now we need, at the moment it's not fixed, it's floating. And we need to put some mates in on that. So I'm going to look for that that's the plane I want to mate up with the plane on the front plane, which is this one here, because that's coincident. So make them coincident. Now that's round the wrong way, so I'm just going to flip the mate alignment so that it's right. So now that's constrained to the center line of the assembly. And now I'll put one more mate on there. So this mate there, the top plane and the top plane of the assembly. So I'm going to add a mate. Now the top plane of the assembly isn't quite in the right spot, and so you can see the heating element pokes up a little bit. So what's got to happen is we've got to make a distance mate from that, and that looks like it's about 10 millimeters around the wrong way. Just flip that dimension, and that's looking a lot closer. In fact, I think that's more like 8. Okay. So now that's in the right spot. The only way that they can move is backwards and forwards, and you can see where the cable goes down there. So that's approximately the right spot, and so I can make a mate between, let's say, the face of the heating element and this face of the fan, and put a distance mate on that, and it's about 30 millimeters. So there we have it. We've included 2 existing components. There's also a switch that can go in here. That needs to be positioned. I'm not going to do that now, but that's something you'll have to do. Now, one final thing that will do for today, but the next step will be to open up these individual components. So you right click on it, go open part, and then we can start putting details in here. So this has a mesh, for example, in the middle, and we can start adding that. This is the grill that goes over the end of the hairdryer. This is what it's going to end up looking like, something like that. I'm going to show you 2 different ways to make the grill pattern, and one is by using a sketch pattern, and the other one is to use a fill pattern. So I'll show you the sketch pattern first. So I'm going to create a sketch on the front plane, and I'm just going to reorient the sketch to that plane so we can see what's going on. I'm going to create a circle on the origin. I'm going to make that circle 3 millimeters in diameter. And now I'm going to go to linear sketch pattern, and I'm going to create a sketch pattern of that circle. So with sketch pattern, you've got 2 directions that you can select to create the pattern in. You can also change the angle of that pattern. I'm going to change the angle to 45 degrees in the first direction, and you can then select the number of instances you want, and you can select the distance between the instances. So the distance between instances we're going to set at 4 millimeters, and that will give us 8 instances before we get to the edge of the face that we're working from. So from the y-axis, again, we can select the number of instances we want. We can also select the angle that we want from that y direction. So we're going to put in 135 as the angle we want, because we essentially will have this pattern going in 45 degrees in one direction and 45 degrees in the other direction. The number of the spacings, we want to have 4 millimeters, and the number of instances, we'll just increase that until we get to the edge. And so that's 8 instances in this case. Hit OK, and we have all our components there. Now I'm just going to get rid of all the instances that go beyond the face that we want. Obviously we don't want holes cutting through the outside edge, just that face. So that's looking about right. Okay, the next thing we're going to do is to select all these components other than the center one, and we're going to create a circular pattern around that. Now automatically it's selected the origin as the point that it rotates around, that it creates the pattern around, and it's also selected 4 instances of those patterns. If we'd selected 3, we'd have that, 2 would be like that, 4 is obviously what we want because we had created a quarter of them. That gives us our pattern. Now we're just to make we just select cut and through all, and there we have our grill with all the holes. Might have been better to delete these ones here on the edge, but that's okay. The other way is to use a fill pattern, and that's a dedicated feature that does exactly that, but to be honest, it is fraught with a few little things that don't always work very smoothly, so let's just see how this goes. So going to insert pattern mirror and select fill pattern. You can see there's a lot of other options for patterns. Now, first thing it asks for is a fill boundary, and so that's the face that we want. It actually needs a sketch, so before we start we'll have to create a sketch that has that boundary that the pattern needs to sit within. It also needs a direction as well, and that needs to be in a sketch or a vertex or an edge rather. So let's just drop out of that for the moment. Again, on the front plane, create a sketch, and we're going to select this line here and convert entities. So that gives us our boundary. The second thing we need is a direction, so we're going to select center line. It's important to use center line and not a filled line. So let's select that. Now we can create our pattern. So go to fill pattern, and now it's automatically select the boundary because the sketch was already selected. If we go down to our direction, we can select that direction. Now we've got a few different types of patterns. We've got a perforation pattern, we've got a circular one, a square, and a polygon. So we want circular. The first one is the spacing between the concentric circles of the pattern. The second one is the spacing between the instances. So we want that at 4 millimeters diameter. The next option is the margin inside the boundary line that we've created. So we're going to put that quite tight at 0.5 of a millimeter. Then we'll just skip over the validate count for the moment. Under features and faces, we have an option of selecting features and faces to make a pattern from, or we can do a seed cut. So this gives us an option of different types of cuts. We can have a circular cut, a square, diamond, or a polygon. We want circle in this case, so we'll need to give it a dimension, a diameter. We want 3 millimeter diameter hole. Next, it'll need to have a starting point for the hole. So we're going to select the origin as the starting point. That should be enough information to get it to cut. So we'll hit OK. Now we have a very neat pattern, and you'll see this is a circular pattern rather than a linear pattern. So those two options that I've shown you produce different results. Not saying one's easier than the other, but there you go. There are lots of options. You can create all sorts of different shapes as well with the actual cut profile. So I'll leave that up to you.